Let's factor binomials. Think about those anyway. When we go to factoring binomials, of course here what we're starting with is a binomial, so we only have two terms to start with. And one such example is x squared minus 25. Now, what it turns out you want to be looking for on binomials is you want to look for special things. In this case, what we might note here is both of these terms in my binomial are squares, perfect squares. Obviously, x squared is a square. What about 25? 25 is 5 squared, right? 5 squared. 5 to the second power is what we're saying. Okay, those being perfect squares. Well, if you do have perfect squares, you do also want to factor this into two binomials. Yeah, it turns out perfect squares with a minus in between them, we'll talk about if it's a plus between them in just a second, but if it's a minus in between them, perfect squares that is, yeah, it's going to be two binomials. I've got x squared, well that's x and x. Then the other parts, of course, come from 25, and yeah, you're going to want to split that up. We said it was a perfect square. We want to factor it up accordingly as 5 and 5. It's a minus 25, so one needs to be a minus, the other needs to be a plus. Turns out factoring ones like this way will work because, why does that work? Well, the reason it works, if you check this by foiling, what happens? X and x is x squared. X times 5 is positive 5x. Minus 5 times x is minus 5x. Minus 5 times positive 5 is minus 25. What happens is, the reason this works, don't the middle terms cancel out? And you get x squared minus 25. That's why this works, because the middle terms cancel each other out. Okay? Just identifying that it is squares is the name of it. All right. So again, here's binomials, two terms. And are these squares? 49, is it a square? 7 squared? 7 squared is 49. It may not be as familiar there. 144? 12 squared? Yeah. And again, the key is, other than those being squares, is that it's a difference of squares. There's a minus between them. So yeah, we checked it off that it's squares, but we also have to be that this is a minus, a difference between them. And it is. And so it, just like our example previous there, it's going to be two binomials. Now, what am I going to do with 49y squared? That's a big number, but since it's a squares, difference of squares, yeah, you're going to break it up. 49 is going to be 49y squared is going to be 7y and 7y. You want the exact same thing both places. 144z squared, same thing. You want the same thing here and here, which would be 12z and 12z, wouldn't it? Lots of ways to break down 144, but since it's a difference of squares, you want the same thing on both of them, except one's a minus, the other's a plus. And it doesn't matter which one. That's it. So it's a pretty direct route there to it, a lot different than the trinomials. Okay? Now, said I'd mention sum of squares, so let me mention sum of squares. Well, there's a problem you run into with the sum of squares. Let's say we had x squared plus 25. We just did x squared minus 25. Let's think about x squared plus 25. Well, if it's going to work, it's got to be x and x for two binomials. 25 is 5 and 5. But it's a plus 25, so that's pretty limited. You got to do plus 5 and plus 5, but why not? Well, if you check that, do the terms cancel out? X squared plus, that'd be 5x, plus 5x, plus 25. Those don't cancel out, they actually double up, don't they? It's x squared plus 10x plus 25, not what we needed. So no, that wouldn't work. The two minuses, we did two minuses, same thing, they wouldn't cancel out. And of course, if you did one a positive, one a negative, that's not right either, because that's not positive 25, that's negative 25. No. There is not, over the real numbers, a way to factor a sum of squares. A sum of squares is prime. Can't factor it. So that minus in between them is important to be able to factor it. If it's a plus between them, no factoring it. So this one is prime. X squared, let's say 64x squared plus 81. Yeah, those are squares. That's a square. 8 squared, 9 squared. However, it's a plus between them. Unless it has a GCF or something like that. But okay? Question or concern? Sum of squares is prime. The difference of squares, we'll be able to factor it, but not a sum of squares.